Last learning objective of this module is about table query and table join. So first we talk about table join, which we have seen in the context of our DBMS operators, but there is more to table join because there are multiple types of ways we can join tables. The one we saw before is also called inner join or simple join. And this is where the output row is created only from the rows that match on the join attributes across the tables. So in this case, the join attribute is type in the two tables. And the only entries that match on both sides are AG and GM. SP appears on this side, but not on this side. FR appears on this side, but not on this side. So when we create the join, inner join, then SP and FR are ignored or omitted. But that's not true when we do the outer join. In case of outer join, the non-matching information is replaced with blanks. So when we do an outer join, you can see that AG is joined with AG, GM is joined with GM. Of course, SP cannot be joined because there is no SP on this side. But what happens to FR? Well, for FR, we just put blanks wherever the code value, because we don't have the code value for these FR values. So this is called the outer join. In real life applications, both types of joins are seen depending upon the need. Sometimes we do need to create an outer join, and we are fine with these blanks because maybe we are interested in the other columns. But either way, both of these conditions can appear. The other thing that we need to consider when we are joining is what type of relationship exists between the two columns. So when we have a foreign key and the primary key, there could be a one-to-one relationship or a one-to-many relationship. And in both of these cases, the output of the join would be affected. So one-to-one is where a unique value on the source table matches to a unique value on the target table. And one-to-many is that it may be unique on the source, but there could be multiple rows in the target table that match. For example, for X, we have 2 matches, and for Y, we have 3 matches. And in the join process, in this case, all of these matches will show in one-to-many, and in case one-to-one, only the matches that exist will show. And these two examples should explain the concept. Something that we want to avoid in join process is many-to-many relations, because in that case there is no way to predict what the output table would look like. The tables that exist in a relational database, we can also combine multiple tables, more than 2 tables, as long as we follow the join rules that we discussed earlier, whether we're doing inner or outer or one-to-one or one-to-many. And so we can look at this process as a reverse of the normalization. In normalization, we had a flat file, and we went backwards to create tables accompanied with a schema to explain that relationship. And in case of joining, we are taking these individual tables and their rule in the schema that joins them and creating an output flat file. The next thing we want to talk about is table query. Now, table query basically uses the restrict operator, and it finds a subset of the rows that satisfy a certain condition. And these conditions are on the attributes of the rows. A simple condition could be, for example, in this table, that area is greater than 20. So all the rows where area is greater than 20 are selected in this. You have probably used this this process of query in ArcMap where you do selection by attribute. We can also use the logical operations that we learned earlier, for example, and, or, and not, to combine multiple conditions in the restrict process. For example, if we want to find all the records with land is equal to urban and municipality equal to city, then and means both of these conditions have to be true. So land use is equal to urban is true, and municipality is equal to city is equal to true, only is satisfied by this first row and the fifth row. So these are restricted or selected in the process. Likewise, when we are looking at the OR operation, then either or the two conditions need to be true, and the only condition when it won't be selected if both of them are false. So if we look at the first row, the area is not greater than 20. So this is not satisfied. But this one is satisfied. Municipality is equal to city. If we look at the last one, the area is greater than 20. That is satisfied. But municipality is equal to city is not satisfied. It's township. But either one of these conditions can be satisfied and would result in the subset. So you can see all the rows where any of these is satisfied has been selected. The not selection process basically reverses the condition. So if we say find all the records where land use is not urban, so you can find the land use wherever there is land use is equal to urban, and then do the complement of that. So everything where it's not urban is selected, which is pretty straightforward. Now, these and, or, and not operations can also be combined to make more complex selection conditions. But something that has to be kept in mind is the precedence of the rules, or how these are to be combined. Just like how we do multiplication before we do addition or subtraction, or even before that we respect the parentheses in mathematical calculations. We do the same thing in logical operations. So parentheses must be respected or used first and foremost. Then all the not operators should be performed, then and lastly or. So and is equivalent to multiplication and or is equal to addition. So multiplication always comes before addition. You can think of that way as well. So here is a very complex selection for this table, that land use is equal to urban and mill rate is equal to B. So this is all in square brackets, then ORed with another curly brackets condition that municipal city is not and density is greater than 200. So when following this, you have to obey all of these conditions in that particular and combine them with the correct order to get the answer. So if we look at this, starting with the first part, so land use is equal to urban and mill rate is equal to B. So both of these conditions, first let's see if both of them are, if they're both satisfied, this will give us true. If any of them is satisfied, then and the other one is not, then it will give us false. Similarly here, when municipality is equal to city, is not equal to city, then this will give us true. And when the density is greater than 200, then this will give us true. And when either of these is true, then the whole condition will give us true. So if you apply these conditions over here, you can see that only number 3 and 5 will satisfy the two conditions. Where if we look at the land use and mill rate, you can see that in this case land use is urban and mill rate is B, whereas in this case land use is suburban, and mill rate is C. So in this case, this side is giving us false, but if we look at the second part, municipality is not city, and density is greater than 200. This is giving true. So true, false, or true gives us true. And so number 3 is selected. And if you look at number 1, then you can see that it fails on, it's false here and false here. False here because mill rate is not equal to B, and false here because the municipality is city, and it should not be city for it to be selected. So make sure you pay some, give some time here and try to make sure you understand how this complex selection is applied here. Here's another example where we have a complex combination of two attributes, but then not is applied at the end. So land use is equal to urban and municipality is equal to county. So this gives us only one row, number 7, where it's urban and county. But when we apply not at the end, then we complement it. So all of the other rows are selected in the restrict process. Okay. Try this example and see if you can find the restrict operator and match it what the table shows.